Competitive positioning, analyzing China and Russia's Mars missions and implications for U.S. dominance. The international landscape of space exploration is undergoing significant transformation, particularly regarding Mars missions. With China planning its Tianwen-3 mission for 2030 and Russia set to follow with its Mars mission in 2031, the implications for U.S. dominance in space exploration are profound. This report delves into the details of these missions, the competitive dynamics at play, and the potential consequences for the United States and global space governance. China's Mars ambitions, the Tianwen-3 mission. China's space program has rapidly advanced in recent years, marked by the success of the Tianwen-1 mission, which successfully orbited and landed a rover on Mars in 2021. Building on this accomplishment, China is now developing the Tianwen-3 mission. Intended to be a sample return mission that aims to collect approximately 500 grams of Martian soil and rock samples. The mission is expected to launch around 2030, with samples anticipated to return to Earth by 2031. Mission architecture and challenges. The mission is designed to rely on a simpler architecture compared to NASA's Mars Sample Return (MSR) mission. It will utilize two Long March 5 rockets, one to deliver a lander and ascent vehicle and the other to place an orbiter and return module into orbit. The lander will be equipped with a robotic arm for surface sampling and potentially a drill to extract subsurface samples. Moreover, the mission may include a small aerial vehicle akin to NASA's Ingenuity helicopter to expand sample collection capabilities. Despite its apparent simplicity, the mission faces significant technical challenges. These include achieving autonomous landing, effective sample collection, and successful orbital rendezvous with the return module. However, China's experience with the Tianwen-1 mission provides a solid technical foundation, enhancing the likelihood of achieving these objectives successfully. Potential landing sites. Recent updates from the China Academy of Space Technology (CAST) have identified 3 potential landing sites for the Tianwen-3 mission: Amazonas Planitia, Utopia Planitia, and Chryse Planitia. Chryse Planitia is of particular interest due to its geological history, which suggests the presence of past water, an important factor in astrobiological studies. Russia's Mars mission plans. In parallel, Russia has announced its plans for a Mars mission set to launch in 2031. However, details surrounding this mission remain sparse, making it challenging to fully gauge its potential impact. Russia's renewed interest in Mars exploration reflects a broader trend of increasing competition in space. But the lack of clarity on technical specifications and objectives raises questions about the feasibility and scientific value of their mission. Historical context. Russia's space program has faced numerous challenges in recent years, including budget constraints and technological setbacks. The lack of detailed planning for the 2031 Mars mission suggests that Russia may be trying to reassert its presence in planetary exploration following years of diminished capabilities. This re-entry into Mars exploration signifies a potential revival of Russian space ambitions, but also adds uncertainty to the competitive landscape. Implications for U.S. space dominance. The missions planned by China and Russia pose a direct challenge to U.S. space ambitions, particularly as NASA grapples with budgetary constraints and scheduling uncertainties regarding its Mars sample return mission. The U.S. plan has faced potential delays due to fiscal concerns, contrasting sharply with China's clear timeline and preparations. NASA's challenges. NASA's Mars Sample Return mission is considered a pivotal project for maintaining U.S. leadership in planetary science and international cooperation. However, recent reassessments have led to deferrals in spending decisions for this mission, raising concerns that the U.S. could fall behind in the race to return samples from Mars. The comparative clarity and ambition of China's plans may allow it to secure Martian samples first, potentially reshaping the narrative of global leadership in space exploration. Strategic priorities. A significant commonality between the missions of China and Russia is the recognition of sample return missions as a strategic priority. Planetary science decadal surveys underscore the importance of these missions for enhancing scientific knowledge and fostering international collaboration. A successful sample return mission could provide unique insights into Mars' geological history and the potential for past or present life, further enhancing the scientific prestige of the countries involved. Timeline of events. 1. 2021, China successfully launches Tianwen-1, marking its entry into Mars exploration. 2. 2023, China announces progress on Tianwen-3, targeting a 2030 launch with samples to be returned in 2031. 3. 2023, NASA reassesses its Mars sample return mission amidst budget concerns. For 2024, Russia outlines plans for a Mars mission scheduled for 2031, though details are sparse. Conclusion. The competitive landscape of international space exploration is evolving, with China positioned to potentially lead the way in Mars sample return missions. The implications for U.S. hegemony in space are significant as budgetary and scheduling challenges threaten the viability of NASA's plans. As China and Russia advance their Mars missions, the U.S. must reassess its strategies to maintain its leadership role in planetary science and global space governance. The outcomes of these missions could reshape the dynamics of international cooperation and competition in space for years to come. The competitive positioning of China and Russia in their Mars missions set for 2030 and 2031 respectively presents several counterintuitive aspects regarding the implications for U.S. dominance in space exploration. 1. China's simplified approach versus U.S. complexity. It may seem logical that a more complex mission design would inherently lead to a greater chance of success. However, China's Tianwen-3 mission, which adopts a simpler architectural strategy compared to NASA's Mars sample return MSR mission, may actually increase its likelihood of success. The streamlined design reduces the number of variables and potential points of failure that come with more sophisticated technology. This approach could allow China to execute the mission more efficiently and effectively, directly challenging the U.S. space program's historically dominant position. 2. Russia's vague plans and potential surprise. While Russia's Mars mission details remain unclear, the uncertainty could play to its advantage. In competitive scenarios, a lack of information can be misleading and may lead rivals to underestimate a competitor's capabilities or intentions. This could allow Russia to develop innovative technologies or strategies under the radar, potentially enabling it to achieve objectives that the US or China might not anticipate. 3. NASA's budget constraints versus international competitors. The U.S. space program is facing significant budgetary constraints and scheduling uncertainties, which is a surprising development given the historical context of U.S. leadership in space. Counterintuitively, this might enable China to gain an upper hand not through superior technology but rather through more effective resource allocation and commitment to its space exploration goals. The decrease in U.S. investment could lead to a relative decline in its global influence in planetary science. For sample return missions as strategic priorities, the emphasis placed on sample return missions by both China and Russia suggests a shared recognition of their strategic importance, which contrasts with the U.S. focus on complex mission architectures that may not prioritize sample return to the same extent. This shared priority could foster unexpected international cooperation or competition dynamics, potentially reshaping how planetary science is approached globally. 5. Timing of launch windows. The timing of Mars missions is critical given that launch windows for interplanetary missions are limited. China's slight adjustment in its timeline, targeting 2030 for launch and 2031 for sample return, may be perceived as a delay. However, it aligns with the next optimal launch window. This could allow China to effectively position itself ahead of the US and Russia, contradicting the notion that a delayed timeline equals a loss in competitive edge. 6. Potential for scientific collaboration. The increasing competition might lead to a counterintuitive outcome: greater international collaboration. As nations recognize the costs and complexities of Mars exploration, They may find it more beneficial to collaborate on scientific missions rather than compete, which could ultimately enhance scientific knowledge and understanding of Mars. 7. Perception of technological superiority. There exists a common perception that the U.S. technology and engineering prowess is unrivaled in space exploration. However, China's rapid advancements in space technology, evident from its successful Tianwen-1 mission and robust plans for Tianwen-3, challenge this perception. The potential for China to achieve significant milestones in Mars exploration could redefine narratives around technological superiority. In summary, the competitive dynamics between China, Russia, and the U.S. regarding Mars missions reveal several counterintuitive insights that challenge conventional assumptions about dominance, complexity, and the nature of international cooperation in space exploration. The implications of these missions extend beyond mere scientific achievement, potentially reshaping global leadership and collaborative frameworks in planetary science for years to come. The competitive landscape of Mars exploration is often viewed through the lens of technological advancements and mission timelines, but there are several nuanced aspects of the report regarding China's Tianwen-3 mission and Russia's upcoming Mars plans that many observers might overlook. These overlooked elements have significant implications for international relations, scientific collaboration, and the future of space exploration. 1. Geological significance of landing sites. One essential aspect of China's Tianwen-3 mission is the careful selection of landing sites, specifically Amazonas Planitia, Utopia Planitia, and Chryse Planitia. While the report mentions these sites briefly, the geological implications are profound. Chryse Planitia in particular is highlighted as having potential evidence of past water flow, which is crucial for astrobiological studies. This geological context is significant because it not only influences the scientific objectives of the mission but also the broader narrative of Mars as a candidate for past life. The importance of these landing sites can be understated. They are not merely random choices but are informed by extensive geological surveys and theoretical models of Mars history. The data collected from these regions could reshape our understanding of Martian geology and, by extension, the evolution of terrestrial planets. A successful mission could provide data that has implications for planetary science as a whole, enhancing our understanding of the conditions necessary for life and the processes that govern planetary development. 2. Technical autonomy and strategic competence. China's approach to the Tianwen-3 mission emphasizes a simpler architecture compared to NASA's complex plans. The report notes that this could allow for a more efficient execution of the mission. However, the significance of this technical autonomy is profound. It indicates a strategic choice to leverage previous successes like Tianwen-1 and build on existing technologies rather than developing entirely new systems, which can be time-consuming and costly. This reflects a broader trend in international space exploration where countries are prioritizing pragmatic approaches to achieve objectives efficiently. The ability to execute complex tasks autonomously, such as landing and sample collection, is indicative of a maturing space program capable of independent operations. This could ultimately enhance China's standing as a global leader in space exploration, inviting further collaboration with other nations or even positioning it as a counterbalance to U.S. initiatives. 3. Russia's ambiguous objectives and strategic positioning. The report mentions Russia's Mars mission plans for 2031 but notes that specific details remain vague. This ambiguity can be significant in the geopolitical context. While it may seem like a lack of clarity, it allows Russia to maintain strategic flexibility. By not disclosing detailed objectives or technologies, Russia can engage in diplomatic maneuvering, potentially aligning itself with other nations that feel sidelined by U.S. space policies. Moreover, the vagueness surrounding Russia's mission might be a tactic to gauge international responses or to collaborate with other countries in a more unified front against U.S. dominance in space. The broader implications of Russia's involvement in Mars exploration could lead to shifts in alliances and partnerships, especially as space becomes a more contested domain. 4. Implications of sample return missions on global leadership. The report highlights the strategic importance of sample return missions as a priority for international cooperation and scientific advancement. However, the implications extend beyond mere scientific inquiry. The race to be the first to return samples from Mars is not just a matter of prestige, it carries significant geopolitical weight. The nation that successfully returns Martian samples could assert dominance in planetary science, influencing international research agendas and collaborations. This scenario could lead to a reconfiguration of leadership in space exploration. If China successfully returns Martian samples ahead of the US, it could redefine the narrative of US superiority in space, prompting shifts in funding policy and international partnerships. The potential for scientific breakthroughs tied to these samples makes the stakes incredibly high, as they could provide insights not just into Mars but into Earth's own geological and biological history. 5. NASA's internal challenges and strategic reassessment. NASA's ongoing reassessment of its Mars Sample Return (MSR) mission due to budgetary constraints is a critical aspect that could go unnoticed. This internal struggle not only affects the timeline of U.S. missions but also raises questions about the sustainability of U.S. leadership in space exploration. The potential delays in MSR could create a vacuum that other nations, particularly China and Russia, might exploit. The implications of these budgetary concerns are significant. If NASA cannot secure funding and adhere to its timelines, it risks ceding ground to competitors who are clearly making progress. This could result in a loss of not only scientific leadership but also technological edge in the long term, affecting U.S. interests in international collaboration and commercial space ventures. 6. International collaboration versus competition. While the report emphasizes competition among nations, it also hints at the potential for international collaboration. The Planetary Science Decadal Surveys recommend sample return missions as a top priority, which underscores the consensus in the scientific community regarding the importance of these missions. This presents an opportunity for countries to collaborate rather than compete. The potential for collaborative efforts in Mars exploration could lead to shared resources, data, and expertise, which would be beneficial for all parties involved. However, the competitive nature of the current landscape could hinder such initiatives. The dichotomy between collaboration and competition is a crucial factor that could dictate the future dynamics of international space exploration. Conclusion. The competitive positioning of China's and Russia's Mars missions in the context of U.S. dominance provides a multifaceted view of international space exploration. The overlooked details regarding geological site selection, technical autonomy, Russia's strategic positioning, implications of sample return missions, and NASA's internal challenges reveal a complex interplay of science, politics, and technology. Understanding these nuances is vital, as they will shape not only the future of Mars exploration but also the broader landscape of international relations in space. 1. China's strategic Mars mission, Tianwen-3. China's Tianwen-3 Mars sample return mission, set for around 2030, signifies a significant step in the nation's ambition to establish itself as a leader in space exploration. The mission aims to return approximately 500 grams of Martian soil and rock samples, focusing on locations with geological histories indicative of past water flow, which is crucial for astrobiological studies. The mission's simplicity compared to NASA's plans, coupled with China's solid foundation from the successful Tianwen-1 mission, enhances its likelihood of success. The choice of landing sites such as Chryse Planitia, known for its potential evidence of past water, underscores China's strategic focus on astrobiological relevance. This mission not only reflects China's growing technological capabilities but also positions it to potentially lead in significant scientific discoveries, thereby challenging U.S. dominance in planetary science. 2. Russia's involvement and ambiguity. Russia's Mars mission, scheduled for 2031, adds complexity to the competitive landscape but remains clouded in uncertainty due to a lack of detailed information on objectives and technologies. While Russia's participation might seem less impactful compared to China's well-defined plans, it still represents a notable shift in international competition in space exploration. The ambiguity surrounding Russia's mission could imply a potential vulnerability, as unclear goals may hinder the effectiveness of its endeavors. However, Russia's historical prowess in space technology cannot be overlooked, and its involvement could catalyze collaborative efforts or intensify competition. The implications of Russia's plans warrant further exploration, particularly regarding its potential partnerships or technological innovations that could influence the broader space race. 3. Implications for U.S. space dominance. The advancements of both China and Russia in Mars exploration pose a direct challenge to U.S. space dominance, particularly as NASA grapples with budget constraints and scheduling uncertainties in its Mars Sample Return (MSR) mission. The U.S. mission faces potential delays while China is systematically progressing towards its goal. This juxtaposition raises concerns about the U.S. maintaining its leadership in planetary science. The ongoing reassessment of the MSR mission indicates a need for the U.S. to urgently address fiscal challenges to keep pace with its competitors. The implications of this competition extend beyond national pride. They could reshape global scientific collaboration and influence international policies around space exploration. 4. Trends in international space exploration. The Mars missions of China and Russia reflect a broader trend of intensifying international competition in space exploration, characterized by nations prioritizing sample return missions. This aligns with recommendations from planetary science surveys advocating for such missions to enhance global scientific knowledge and collaboration. The recognition of sample return missions as strategic priorities indicates a shift towards cooperative frameworks, potentially fostering international partnerships. However, the race also highlights the geopolitical tensions that can arise from space exploration as nations vie for leadership and prestige in this high-stakes arena. The evolving landscape necessitates continuous analysis of how these missions can influence global cooperation, competition, and the future of planetary science. 1. The Space Race 1957–1969, the competition between the United States and the Soviet Union during the Cold War to achieve significant milestones in space exploration. The launch of Sputnik by the Soviet Union in 1957 marked the beginning of the space race, leading to key events such as the first human in space, Yuri Gagarin. 1961 and culminated in the Apollo 11 moon landing by the U.S. in 1969. This period was characterized by technological innovation, intense national pride, and geopolitical implications, ultimately influencing global scientific and military advancements. 2. The Sino-Soviet Space Cooperation 1950s to 1970s, a significant collaboration between China and the Soviet Union during the early years of space exploration. Influenced by ideological affinities, this partnership included shared technologies and knowledge concerning rocket development and satellite launches. However, the relationship soured in the late 1960s, leading to a split in competition between the two nations in their subsequent space endeavors. The historical significance of this cooperation and subsequent rivalry reflects the complexities of international relations and technological advancements in space exploration. 3. The Mars Exploration Program 1990s-present, a series of missions led primarily by NASA aimed at exploring Mars, which highlights the evolving competitive landscape in space. The successful landing of the Mars Pathfinder in 1997 was a pivotal moment, establishing a foundation for future explorations. In the 2000s, missions such as the Mars rover Spirit and Opportunity further advanced our understanding of the planet. The recent collaborations and competition with countries like China, which successfully landed the Tianwen-1 rover in 2021, illustrate the ongoing race for planetary exploration and the implications for international dominance in space science and technology. The competitive positioning of nations in the realm of Mars exploration is expected to evolve significantly by 2030 and beyond, particularly with China's Tianwen-3 mission plan for 2030 and Russia's mission set for 2031. These initiatives pose serious implications for the United States' historical dominance in space exploration, especially as NASA grapples with internal challenges. Future predictions for China's Mars mission. 1. Successful sample return, given China's track record, particularly with the Tianwen-1 mission. It is likely that the Tianwen-3 mission will succeed in its objective of returning Martian soil and rock samples. This could position China as the first nation to achieve a Mars sample return, thereby enhancing its reputation as a global leader in space exploration. 2. Advanced technological capabilities. The Tianwen-3 mission is expected to showcase China's growing technological capabilities, particularly in autonomous operations and complex mission architecture. The successful implementation of these technologies may inspire further advancements and increase international collaborations. 3. Scientific discoveries. The analysis of Martian samples could yield significant scientific discoveries, potentially revealing evidence of past life on Mars. This would not only contribute to our understanding of Mars but also strengthen China's scientific community and capabilities. Future predictions for Russia's Mars mission. 1. Technological revitalization. Russia's re-engagement in Mars exploration, although vague in details, may signal a revival of its space program. Should Russia successfully execute its Mars mission, it could revitalize its status as a formidable player in space exploration. 2. Collaboration with other nations. Russia's Mars mission could lead to potential partnerships with other countries, possibly combining resources and expertise, which would be a strategic move to regain its footing in the international space landscape. 3. Geopolitical implications. Russia's involvement in Mars exploration may also be viewed through a geopolitical lens. As it aims to demonstrate technological prowess, there may be implications for international relations, particularly with Western nations. Implications for U.S. space dominance. 1. Potential decline in leadership. The prospect of China and Russia achieving significant milestones in Mars exploration could challenge the U.S.'s long-standing dominance. If NASA continues to experience delays and budgetary issues, it risks falling behind in the global space race. 2. Increased competition. The competitive landscape is likely to intensify, prompting the U.S. to reassess its strategies and investments in space exploration. This may lead to an increased focus on innovation and collaboration with private space companies. 3. Strategic policy shifts. The U.S. government may need to implement strategic policy shifts to ensure that NASA remains a leader in planetary science. This could include increased funding for Mars missions and fostering international partnerships to share knowledge and resources. 4. Public and political pressure. As China and Russia make strides in space exploration, public and political pressure in the U.S. may mount for a renewed commitment to space initiatives, potentially leading to bipartisan support for increased funding and strategic planning. Broader implications for global space exploration. 1. Shift in global leadership. The successes of China and Russia in Mars exploration may signal a shift in global leadership in space science, with implications for international collaboration and competition. 2. Increased investment in space programs. Other nations may feel compelled to invest more in their space programs as competition heats up. This could lead to a diverse array of missions and collaborations that advance scientific knowledge on a global scale. 3. Focus on international collaboration. The recognition that space exploration transcends national interests may spur increased collaboration among countries. Joint missions and shared research could become more common as nations seek to optimize resources and knowledge. 4. Public interest and engagement. A competitive landscape in space exploration could invigorate public interest and engagement in science and technology, inspiring a new generation of scientists and engineers. Conclusion. The Mars missions planned by China and Russia for the coming decade represent significant milestones that could reshape the international landscape of space exploration. As the U.S. navigates its challenges, the implications of these missions extend beyond mere competition. They touch upon technological advancement, geopolitical dynamics, and the collaborative spirit of human exploration. The coming years will be critical for all nations involved in space exploration as they seek to define their roles and aspirations in the quest for knowledge beyond our planet.